Rahim Keralari. Suppose that the set S consists of the elements V1, V2 up to Vn of the vector space V over the field F are linearly independent vectors, but the set T consists of all the elements of the set S V1, V2 up to Vn, including another vector W of the vector space V over the field F is a linearly dependent set. Then the new vector W is a linear combination of the remaining vector v1, v2 up to vn. Suppose that the set T consists of all the elements v1, v2, vn. W is a linearly dependent subset of the vector space V over the field F. Then by definition there is a scalars a1, a2, an, b such that a1 v1 plus a2 v2 plus up to so on plus an vn plus b w is equal to 0. If if the constant, the scalar b is equal to 0, then equation first implies that a1 v1 plus a2 v2 plus up to so on an vn plus 0 multiplied by w is equal to 0. Since the elements of the set T are linearly dependent vectors, therefore at least one of AI is not equal to 0 to say for I is equal to 1 2 up to n to satisfy the condition that this set is a linearly dependent set of the vector space V over the field F. But the vectors v1, v2 up to vn are linearly independent vectors of the vector space V over the field F, which is a contradiction to our hypothesis that the set S is linearly independent vectors. Therefore, this contradiction arises due to our supposition that the element B, the scalar B, which is in the multiplication with the vector W, is equal to 0. Hence, the element B is we can decide here that the element B is not equal to 0, and so equation first implies that this element is not equal to 0. Add minus bw to both sides, and after that divide the right hand side, the left hand side by minus b. We have w is equal to a1 divided by b, where b is not equal to 0. We can divide the division by a non-zero element is allowed. So in this case the scalar b is we suppose that the scalar b is not equal to 0. In this case, if b is equal to 0 in case first, then there is a contradiction to our hypothesis. Therefore, the W can be written as a linear combination of the remaining elements V1, V2 up to Vn, which are the elements of the set S. Thus, W is a linear combination of the vector V1, V2, Vn, and hence the set T is linearly dependent vectors, which is our required result. That is, the element W of the vector space V over the field F is a linear combination of the remaining vector V1, V2 up to Vn, which is required.